In this lesson, we're going to talk about our atmosphere and the composition of our atmosphere. So what is the composition of our atmosphere? Weather is the condition of Earth's atmosphere at a particular time and place. It's important to note that our atmosphere determines weather. Earth's atmosphere is the envelope of gases that surrounds our planet. Our atmosphere consists of nitrogen, oxygen, carbon dioxide, water vapor, and a number of other gases. It also has particles of liquids and solids floating around in it. Looking at this picture here, we see that about 78% of our atmosphere is nitrogen, 21% is oxygen, and then the remaining 1% is a mixture of carbon dioxide, water vapor, and other gases. Nitrogen. The most abundant gas in our atmosphere is nitrogen. Most of that nitrogen is in the form of N2, nitrogen gas, as you can see in the picture down in the bottom right-hand corner here. Two nitrogen atoms combined together. It makes up about 78% of our atmosphere. Nitrogen occurs in all living things, so you have nitrogen in you. Specifically, about 3% of the weight of your body is nitrogen. So if you were to take your entire weight and divide it by 3%, you would determine the amount of nitrogen that makes up your body. Oxygen. 21% of the atmosphere is oxygen. Most of that oxygen is in the form of O2, oxygen gas. So two oxygen atoms combined together, much like the picture you see in the bottom right-hand corner here. Plants and animals take oxygen from the atmosphere and use it to release energy from their food. And yes, plants do use oxygen gas. During the daylight hours, they go through photosynthesis, where they are taking in carbon dioxide and creating oxygen gas. However, when the sun goes down and it's nighttime, plants don't just stop going through the reactions that occur within their structures. Plants convert into another cycle that allows them to burn oxygen to release energy from food. Fire uses oxygen as it burns. Without oxygen, a fire will not continue to burn. It will go out. And the steel in cars rusts due to oxygen. Carbon dioxide. It's important to note the chemical composition of carbon dioxide is 1 carbon atom to 2 oxygen atoms. Carbon dioxide makes up less than 1% of Earth's atmosphere. It is essential to life on our planet. Without it, plants would not be able to produce the food that they need to supply all ecosystems with energy. When fuels like coal and gasoline are burned, they release carbon dioxide into the atmosphere. And then the other gases that make up our atmosphere. Most of the last 1% of the atmosphere is made up of argon. There are, however, small amounts of other trace gases. Water vapor. Water vapor is an invisible gas found in the atmosphere. The amount of water vapor in the atmosphere varies depending on the location. So, for example, Michigan. We typically have high humidity in the summer. The reason we have higher humidity in the summer is because of our Great Lakes surrounding our state. A lot more evaporation occurs during the summer months in our state, just simply due to the fact there's a lot more available water. Clouds form when water vapor condenses out of the atmosphere. So that water vapor that is evaporated floats around in the atmosphere. It eventually will condense. The clouds may become large enough to allow water droplets to form. And as the droplets stick together, they become precipitation. Particles found in our atmosphere. Air contains small particles of dust and debris. It may contain tiny solid and liquid particles of dust, smoke, salt, and even chemicals. These materials are extremely useful when helping condensation occur. We call these condensation nuclei. And without these small particles of dust floating around in the atmosphere, we would not have water vapor condensing. So the water vapor sticks to the small condensation nuclei, and it allows drops of water to form. How is the atmosphere a system? The atmosphere is a system that interacts with other Earth systems, such as the ocean. The atmosphere has many different parts. Some of these parts you can see, such as clouds, but most parts of the atmosphere, like air, wind, and energy, we cannot see. We can feel them, we know they're there, but we can't see them. Events in one part of the atmosphere affect other parts of the atmosphere. Energy from the sun drives the motions of the atmosphere. The way in which we have wind is due to the temperature differences on our planet. So as temperature increases in certain areas, molecules move up. So a temperature of an atmosphere, as the temperature of atmosphere increases, those molecules gain more energy, they move apart, they become less dense, therefore they rise. As those molecules rise, new molecules have to fill the space that they leave. This creates the air on our planet. A storm like a hurricane involves a tremendous amount of energy. That energy comes from the sun. This is part of the reason why we have hurricane seasons. Without heating from the sun during the winter months, we typically don't have hurricane formation, at least in our part of the planet. The spiraling shape of a hurricane is due in part to forces resulting from Earth's rotation. So not only is our atmosphere controlled by the heating of our planet from the sun, it also is controlled by the rotation that our planet has. A hurricane also gains energy from warm ocean water, and that warm ocean water is created due to the fact that we have heating from the sun. Since a hurricane forms over water, it loses energy as it moves over land. It's important to note a hurricane cannot hit Michigan. Leftover parts from a hurricane, as it's dissipating, can be pushed northward towards Michigan, so we can get mild thunderstorms or mild rain clouds from a hurricane, but those rain clouds are not the hurricane itself. The hurricane has lost all the energy that it had from the oceans as it's pushed up over land. Once it makes its way all the way to Michigan, we cannot have hurricane force winds or the different weather events that are associated with a hurricane.